Good morning. This is the reconstruction of the middle part of session two uh, recording that inadvertently, for some reason, did not get recorded. It's preceded by part one, which is me talking about different factors in the in web courses, the homepage, and so forth. We did some iClicker items and Chuck Norris facts just for practice so you guys can get the hang of using your iClickers in this class. And of course, I noticed that a few of you voted for Justin Bieber on this one, which is completely wrong. But many of you also voted for Chuck Norris, and that was wrong because Bruce Lee actually defeated Chuck Norris. All right, so much for the practice problems. Now, the real stuff. We right after that we did the three dogs plus one problem in the textbook and worked it out. And I don't know if the textbook works this one out in detail, but um, just so you know, sometimes the way I work stuff out is different from the way the textbook works stuff out. So keep that in mind um, and learn from it because sometimes seeing things from two different angles is helpful. And that's actually another benefit of working with a group of three in class because you have two uh, associates, two group members that might see things a little different from you. And then that helps you see more accurately and kind of triangulate in on the concepts. Okay, the problem of three dogs plus one, A, B, C, and D, you had four dogs, and one of them, the pull force was not specified. The objective was for all the pull forces to add up to zero so that they're, this mythical chew toy that they were trying to grab was motionless. Okay, so that means the forces balance. And that means that vector A plus vector B plus vector C plus vector D is equal to zero. And for that reason, if you don't know what D is, you can figure it out from A, B, and C. And so D is equal to minus A plus minus B plus minus C. Now to do that full vector equation, you have to have components for A, B, and C. And so we use sine and cosine to do that, plus the magnitudes given. 140 for A, 200 for B, 160 for dog C. And you work out your components and put together dx and then dy, and then you're golden. You can also figure out the magnitude, using the Pythagorean theorem, 158.1 units of force. And the inverse tangent lets you figure out the exact tilt angle. And then you can make a diagram that looks, that makes sense. Remember, your diagram, you want to look as good as it possibly can, but yet you're not necessarily required to be another Leonardo da Vinci for diagrams. And the reason that you can, you want a nice diagram, but you don't have to be perfect with it, absolutely perfect. You just have to be close enough for government work, is because we're going to let the numbers do the talking. And that's what we've got in here. We've got all the numbers figured out. Down here at the very bottom of the second image, you can see I've broken down vector D into two different expressions. One in terms of its modulus or its length, 158.1, and its directional tilt angle, 18.1 south of west, which you can see in the diagram up there. And then the second way to express that vector is in terms of components, negative 150.3 units of force in the x-axis. So that means negative means left on the x-axis. And then we have negative 49.2 on the y-axis. And so that means downward. This is a third quadrant vector. And that's not a hard guess, but in the end, you let the numbers do the talking. Now, another thing that we did was a little extra. We figured out the directional unit vector for D. And It's basically, figuring out what is a unit vector that points in exactly that direction. And sometimes that's a thing that we've got to know when we're calculating energy or something like that, kinetic energy and work. And so this one is lowercase d with a little hat vector over the top of it. And it's basically just um, the vector itself, which I have in component form in the numerator, and then the length of the vector, 158.1. Now that's a scalar down there. That's a length. It's not a vector. The vectorness is up in the numerator. And in the next step, I break it down into two different components. Now I've got an x component with the I hat vector, and the component, it's the size of the component is that's now a scalar. It's just two numbers. The vectorness is in the I hat vector, and it's negatory. And then the other one is negative 49.2 over the length of the vector itself, 158.1. And that's in the j hat direction. That's downward, negatory, as we know it should be. So the unit vector is a third quadrant vector, and those are those two quotients that work out to -9 is negative 0.9507 and then negative 0.3112. Those are actually directional cosine and directional sine. So the square of those, the sum of the squares of those two components has to add up to 1, and that's what makes it a unit vector. Okay, and so directional cosine, directional sine always show up in this way. And for this particular way that I did it, the directional cosine is in the I hat direction, and the directional sine is in the j hat direction. Okay, I'll do the next part in a different recording.